So today we're going to work on fractions part 3, specifically fraction of a set. Question 1. Express 250 as a fraction of 750. So the way I think about this is, look at this word off over here. I think of the number on the right side as a denominator, right? So we are expecting a fraction for answer, so we are wondering, okay, what number is the numerator, what number is the denominator? Anyway, the way I think about this is, the number on the right hand side is the denominator, right hand side of the word off. Yeah, so 750 is the denominator, 250 is the numerator. Cancel the zeros, and then you get 25 or 75. Divide by 25 throughout, you get 1/3 for the answer. So we've got 1390 meters, and we've got a fraction as a fraction of 2 kilometers. Well, we know for sure that 2 kilometers is the denominator and 130 is the numerator. But we can't leave that as the answer. We have to convert both to the same units. So that's 1390 meters out of 2000 meters. Cancel the zeros, and what do you know? This is the simplest form. Question 3. What fraction of 2 liters is 100 ml? So what fraction of 2 liters? Right, look at this. Of, so the denominator is 2 liters. So we've got 100 ml out of 2 liters. We cannot use 2 liters. We have to change it to ml. So that's 2000 ml. Cancel the 2 zeros, cancel 2 zeros, and we have 1 out of 20. Express 6 months as a fraction of 2 years. So this is the denominator. 6 months out of 2 years. But we cannot have the different units, can we? So 2 years is basically 2 times 12. That's 24 months. 6 months out of 24 months. Simplest form is 1/4. 25 minutes as a fraction of 3 hours. So numerator is 25, denominator is 3 hours. So 25, and then it's not 3 hours, we have to convert that to minutes, that is this. So if we divide by 5 throughout, we can, this is a little trick here, 25 divided by 5 is 5, we know this. Now 6 times 30, 3 times 60 is a big number, isn't it? So how about we just take 60 divided by 5, which is 12. Well, 3 times 12 is much easier, so it's 5/36. Express 30 minutes as a fraction of 2 hours. So conversion is needed because we've got minutes and we've got hours. Look at this word off here. 2 hours is the denominator. So 30 minutes out of 2 hours, 30. Convert this to minutes, that's 2 times 60 minutes. So that's 30/120. Okay, or you can simply convert this to 30, divide by 30, divide by 30. Become 1 and 2. Now, you don't have to do these things. You can just simplify the way you want to do it, right? You should anyway arrive at 1/4. Look at this word off here. So 1 hour is the denominator. 32 minutes out of 1 hour. Okay, convert to minutes for both. 32/60. And then divide by 4 throughout. And then you get 8/15 for the answer. Next 30 seconds, we've got different units here. And the word off tells me 2 minutes is the denominator. So 30 seconds out of 2 minutes, convert both to seconds. So that's 2 times 60. Now again, I'm going to divide by 30, divide by 30. So that's 1 and 2. So it's 1/4. Express 18 days as a fraction of 6 weeks. So different units plus the word off tells me 6 weeks is the denominator. So 18 days out of 6 weeks. Convert weeks to days, which means I'm going to multiply by 7. But before I do that, I know that I can divide both by 6. Yeah, so 18 divided by 6 is 3. 6 divided by 6 is 1. So therefore, 3/7 is the answer. Express 20 minutes as a fraction of 3 hours. So minutes and hours, again, conversion needed. Of, that means 3 hours is the denominator. Okay, convert both to hours. Sorry, minutes. Okay, divide by 20, divide by 20, or yeah, take away 10 and get 2 and 6, and then you simplify, and you should get 1/9. 30 minutes as a fraction of 4 hours. So 4 hours is the denominator. Convert to minutes, take away the 10, simplify, and then 3 and 24, both multiples of 3, convert that to 1/8. Express $1.20 as a fraction of $3. Now, the good news is both are in dollars, but and we notice that $3 is the denominator. Okay, so if you convert that to, if you just multiply by 10, right, it's not going to be 1.2 anymore, it's going to be 12. If you multiply by 10 for the numerator, you must do the same for the denominator. Divide by 6, you will get 2 over 5. So this is written in a different way, but the rule still stands. The word of tells you the number on the right side is the denominator. So 450 grams over 5 kilograms, convert both to grams, multiply by 1,000 here. So take away 1 0, you get 45 over 500, which you can divide by 5, and you will get this. Now, you know 80 minutes versus 2 hours. This number is larger, right? But please do not be thinking the larger number should always be the denominator. Look at this, what fraction of 80 minutes? So 80 minutes is the denominator here. And 2 hours is the numerator. So convert to minutes, you get 120 out of 80, cancel the zeros, you get 12 over 8, which gives us 3 over 2 or 1/2. In this case, it's an improper fraction, right? So again, do not always be thinking the larger number should be below. Nope, it depends on what they're asking. What fraction of 9 meters? So we know 9 meters is the denominator. So 9 meters is the denominator, 50 cm is the numerator, convert to meters, cm, and then cancel 1 0. 5 over 20, 5 over 90, divide both by 5, you get 1 over 18. Express 12 days as a fraction of 6 weeks. So the word of tells me 6 weeks is the denominator. So 12, and then you see 6 weeks, we're going to multiply by 7 so that both are days. Notice I can divide by 6 here and divide by 6 here. So you get 2 over 7. Mrs. Tan bought 2 kg of flour. She used 1 kg and 200 grams. So we've got different units here to bake a cake. What fraction of the flour had she left? You see the word of here? That means the flour that she had at first must be the denominator. So here we've got, well, let's calculate the amount of flour left. 2 kg minus this. This is in grams. This is what's left. But what fraction of the flour? Well, what she had at first is the denominator. What she had left, cancel 2 zeros, you get 8 over 20, divided by 4, and you get 2 over 5. Desmond spends 4 hours each day on tennis training. What fraction of the day? See the word of here? The day in hours must be the denominator. So what's hours in the day? That's 24. So what fraction of the day? So the day's hours, 24 hours, must be the denominator. On tennis training, 4 hours. So divide by 4, you get 1/6. Dan had 63 balloons. He gave away 14 of them. What fraction of the balloons? The word of tells me balloons at first must be the denominator. Did he have in the end? Okay, let's find out what he had in the end. So 63 gave away 14. He had 49 left. What fraction of the balloons that he had at first did he have left? Well, these two are multiples of 7. So let's divide by 7. We get 7 over 9. There were 14 blue pens and 6 red pens in the box. What fraction of the pens in the box? Well, first we need to realize that the denominator is the total number of pens. Well, let's find out. That's blues plus reds. That's 20. Now, what fraction were red? So red is given to us as 6. We know now the total pens is 20. Both are multiples of 2, so divide by 2. You get 3 over 10 for the simplest form. Sean had some sweets. After eating 9, he had 45 left. What fraction of his sweets? Okay, so he had 45 left after eating 9. So if he had not eaten those 9, his total would be 45 plus 9. Yeah. So returning back time, right? Let's say he had not eaten those 9. The total he had would be 45 plus 9. Now, what fraction of his sweets did he eat? Well, he ate 9. So the total left is 45. That means what fraction of the total did he eat? He ate 9, had a total of 54 at first. Simplify, you get 1/6. Next is a question type that is quite popular in booklets A and B. Let's find out. 3/8 of a number is 51. What is the number? Okay, so let's start off with a drawing, shall we? So 3/8 of a number is 51. What does that actually mean? So out of the 8 units, 2, 4, 6, 8 units, 3 of those units represent 51. What is the number? Basically asking the 8 units. What does it represent? So the slow way of doing this is, yes, 3 units is 51. Okay, 1 unit is 51 divided by 3. That's 17. Therefore, what is the number? We are interested in 8 units, are we not? So 8 units, we're going to multiply by 8, giving us 136. Well, the slightly faster method is I'm using equations here. So 3 over 8 units. Now think of this as 3 units out of 8 units, yeah? And this arrow just means, is representing 51. Not equal to, because it's very weird to say 3/8 is equal to 51. 3/8 is not even one whole. How can it be equal to 51, right? So I'm just drawing an arrow to represent 3 units equal 81. 1 unit represent 17. 8 units represent 136. 3/7 of a number is 252, as in 3 units is 252. What is the number, as in what's 7 units representing? So let's draw 7 units, 2, 4, 6, 7. 3 of those representing 252. Okay, so 1 unit will be 252 divided by 3. And what's the number? It's the entire 7 units. So the faster method is to write equations and present them this way. Same exact steps. Same exact answer. 2/3 of Mr. Tan's salary, that means his salary actually is represented by 3 units, and 2 of those units is 3360 actual dollars. How much is his salary? So 3 units, 3360 representing 2 units, and what is the 3 units going to be? So 2/3 is 3360, 1/3 divided by 2, you get 1680. Now his salary is therefore 3 units. So with 1/3 being 1680, 3 units we're going to multiply by 3, and $5,040 is the answer. 2/3 of a number is 18, as in 2 units is 18. What is the number, as in what are 3 units? Okay, so 2 of those units representing 18. So 2/3 is 18. 1 unit is 9. What is the number? All 3 units. That means 9 times 3 gets us 27, okay? 1/4 of a number is 24. What is the number? So 1/4, notice I'm not drawing a model anymore. Just visualize this, right? One of those units is 24. What is the number? All 4 of the units. So that's 96. 3/7 of a number is 105. What is the number? So with equations, 3 units out of the 7 units is 105. 1 unit out of the 7 will therefore be 35. And the number is the entire thing, 7/7. So that's 35 times 7, that's 245. 3/10 of a number is 54. What is the number? Next, 3/10 is 54, so 3 units. 1 unit, we're going to divide by 3. What is the number? So the entire 10 units. 5/8 is 80. What is the number? As in, what's 8 units representing? So 5/8 is 80, divide by 5, so we get 1 unit, that's 16. The number is simply 1 whole, which is 8 out of 8 units, so that's 128. 10/11 is 300. What is the number? So 10 units is therefore going to represent 300. 1 unit, we're going to divide by 10. The number, all 11 units, so that's 330. 2 stars. Half of a number is 60. Well, we can find out what this is first before we work on this. Yeah. So half of a number is 60. So if half of a number is 60, the number is simply, we're going to times 2, that's 120. But the question is not asking for the number, is it? The question is asking for 1/3 of the number, right? So what we're going to do is therefore 1/3 of the number. Well, think of it as taking the number and divide it into 3 pieces. What is each piece? We're going to divide by 3, and it's 40. So 7/9 of a number is 4/49. Okay, we can work with that. 7/9 is 49. So 1 unit is therefore 7. 9 units is 63. But the question is not asking for the number. The question is asking what is 1/3 the number. So 1/3 of 63 is simply taking 63 divided by 3. We get 21. 7/18 of a number is 112. What is half of the number? Okay, let's work with this again. So if 7 units is 112, 1 unit is therefore 16. Now half of the number is also known as 4/8 of the number. Those are equivalent fractions, right? Half of the number is 4/8 of the number. Okay, if 1 unit is 16 and we want 4/8, we just take 16 times 4. The other method is to find the number itself. Okay, so you have 1/8 is 16, right? Find 8 units. You will get the number. And then take that number divided by 2. That's the slower way. 1/3 of a number is 25. So let's work with this first. 1/3 of a number. Okay, I'm being a bit, let's see. I'm using slightly advanced methods here. 1/3 is also known as 5/15. Notice that I'm working with denominators 3 and 5. How about I work with 15? So 1/3 of a number, let's turn it to 5 over 15 of a number is 25. So 1/15 of the number, we're going to divide by 5. What is 2/5 of a number? Okay, what is 2/5? Is 6 over 15, isn't it? So if 1 unit out of 15 is 5, what's 6 units out of 15? We're going to times 6. 1/6 of a number is 6. What is half of the number? Okay, so 1/6 of a number is 6. Now half of a number is also known as 3 over 6. Notice the pattern here. I'm working with identical denominators. So I don't want to work with 6 and 2. How about work with 6? Turn this into 3 over 6. So if 1 over 6 is 6, and the question is asking for 3 over 6, we'll just take 6 times 3. That's 18. Ooh, look at the denominators here. 5 and 2. Okay, so 2/5 of a number is 76. Alright, so 2/5 of a number, how about I call it 4/10 of a number? Yeah, 4/10 of a number is 76. What is half of the number? Okay, instead of saying what's half of the number, what's 5 over 10 of the number? See, now I'm working with 10 as the denominator throughout. That's cool. So 4/10 as given is 76. 1 unit is 19. 5 over 10, which is half, 5 over 10, we're going to times 5 and get us 95. Half of a number is 48. What is 7/8 of the number? Again, I've got denominators that are different, right? 8 and 2. So turn this into 4 over 8. How about that? So 4 over 8. So let's say 4 over 8 is 48. Well, what's 1 over 8? That's 12. What's 7 over 8? We're going to multiply by 7. That's 84. Level 3, the sum of 7 over 12 of a number, okay, and 3/4 of the same number. Hang on. If the number is the same, why should the denominator be different? Because the denominator represents the entire number, doesn't it? So why is the entire number 12 units and 4 units? Shouldn't they be the same? Well, let's turn this into denominator 12, shall we? So, well, 3/4, let's turn it to 9 over 12. So now we can make sense of this. 7 over 12, the sum. So we're going to add that up, right? The sum of these two fractions is 624. Okay, so the sum of these two is 16 over 12. Oh, now I know 16 over 12 of a number is 624. Question, what is the number? In other words, we're interested in 12 over 12. So what you can do is to find 1 unit, which means you take this divided by 16, but I chose not to do that. I'm going to divide by 4. 16 divided by 4 is 4 units. 624 divided by 4 is 156. Now why did I do that? Because from 4 units, I can go to 12 units easily. Just multiply by 3. And doing that, we get 468 as the number. And another level 3, 1/4 of a number is 243 less than 5/8 of the same number. Well, we have the same situation again where we are referring to a fraction of the number, fraction of the same number, but the denominators are different. They should be the same. So I'm going to turn this to 2 over 8 instead and see if that makes more sense. It does. Okay, so 2/8 of a number, which is 2 units out of a total of 8 units, is 243 less than 5/8 of the same number. So the number itself has 8 units, but they're saying 2 parts is 243 less than 5 parts. Doesn't that mean 3 parts is 243? That tells me that 3/8 is therefore representing 243. So what's 1/8? It's 81. What is the number? 8 over 8. That's 648. 1 3/4 of a fraction is 9/10. What is the fraction? Oh my goodness, look at this. Okay, so let's visualize this. First of all, convert this to improper fractions. Okay, so this is the equation then. 7 over 4 of a fraction is 9 over 10. Now let's think of this as 7 units. Okay, what do we normally do? We find 1 unit, don't we? So we're going to divide by 7 to find 1 unit. Now what is 9/10 divided by 7? It is 9 over 70. Okay, what is the fraction? Which means 4 over 4 of the fraction. 1/2 of the fraction. So we're going to take this, multiply by 4. That's 36 over 70. And leaving this in the simplest form, that would be 18 over 35. Another level 3. 3/5 of a number is 2/3 of 360. Okay, this requires you to know something. What is 2/3 of 360? This of here is, think of it as multiplication. What is 2/3 of 360? Well, we can actually find out what the number is. Okay, so let's carry out the first step. What is 2/3 of 360? Wait, hang on. 3/5 of a number is 2/3 of 360. Let's obtain the actual number value here, shall we? So 2/3 of 360 is actually 240. So what that means is the 3 units will represent 240. Look, the 3 units here will represent the 240 here. And we're interested in the number, which means 5 units. Okay, so 3 units represent 240, 1 unit is 80, 5 units is 400. 3 times a number is greater than 3/5 of the number by 36. So there's a difference of 36 between thrice a number. Okay, how do we think of this? So let's call the number 5 units, shall we? Why? Because look at this denominator 5 here. It's easy to do that, right? So what is thrice of the number? That's 15 units, right? If the mysterious number is 5u, what's 3 times of that? 15u. Okay, what's 3/5 of 5u? There's a reason I chose 5u, but because 3/5 of 5u is simply 3 units. So if 15 units minus 3 units, that's going to give us 12 units. I say again, thrice the number. If the number is 5u, thrice the number is 15u. What's 3/5 of 5u? It's 3 units. And they told us the difference is 36. So what that means is 12 units represent 36. What's 1 unit? 3. What is the number? 5 out of 5. So the answer is 15. So this next section is off as in multiply. So off can be thought of at first, at the beginning of the video, off tells you the denominator, yeah? But in this case, off means multiply. Let's take a look. What is 4/7 of 84? Okay, basically it's 4/7 of 84 as in multiply. So simplify diagonally, 7 and 84, that's 1 and 12. So 4 times 12 is therefore 48. Alright, first we're going to take 2/7 of 4.9 liters. Okay, let's do that. Multiply, off in this case is multiply this. Now I'm going to change this to milliliters, which is 4900 ml. Now simplify and you will get 1400 ml. Mrs. Janet bought 5 kilograms of sugar. She used 7/10 of it. Can you see what just happened? I am going to find out the actual kilograms used. Or rather, how much sugar had she left? Okay, actually you don't need to find the amount of sugar used. So if 7/10 got used, that means 3/10 got left. And this is 3/10 as a fraction. This fraction of 5 kg. Okay, what is this 3/10 of 5 kg? As you know, this section, we are focusing on off as in multiply. That's basically 3/10 of 5, giving us is 1.5 kilograms. John had 504 boxes of candies. He sold 7/9 of it. Okay, now, how many boxes left? Well, if 7/9 as a fraction was sold, doesn't that mean 2/9 as a fraction was left? Yeah. So what's 2/9 of the 504? Again, 504 off as in multiply. So 2/9 of 504 is 112. There were 648 adults at the stadium. 4/9 of the adults were men. How many men were there? Okay, we are interested in this fraction being men, right? So 4/9 of 648 and off as in multiply. So simplify diagonally. Okay, that's 4 times 72. That's 288 actual men. There are 49 pupils in the school library. 5/7 are girls. Okay, how many more girls than boys are there? So if 5/7 were girls, doesn't that mean 2/7 were boys? Okay, next, what's the difference? That's what we're interested in, isn't it? How many more girls than boys? In other words, we're interested in 3 units because the difference between boys and girls is 3 units. Girls, 5 units. Boys, 2 units. The difference is 3 units. And what's 3/7 of that 49? Right? What's 3/7 of, as in multiply, the 49? The answer is 21. Jiming had $65. He spends 2/5 of this money on ice cream and another $5 on waffles. How much did he have left? Okay, what's the amount spent on the ice cream? It's 2/5 of $65. So that's multiply. Okay, multiplication, giving us 26 actual dollars. Okay, $5 spent on waffles. So that means the amount of money left would be the total, 65 minus 26. minus 5, giving us $34. So 2/5 of 65. Again, of as in multiply. Now, do not be confused by fractions here. I know there's a fraction here, there's a fraction here, but this is 1/4 as in 1/4 units. This is 4/9 as in actual meters of cloth. Okay, she used 1/4 to sew a pencil case. How much cloth had she left? Now, if 1/4 was used, that also means 3/4 was left. And what actual length of cloth was left is 3/4 of that 4/9 meters. So this requires you to be very familiar with multiplying and division and subtraction and addition of fractions. In this case, multiplication. So simplify diagonally, you get 1/3 actual meters of cloth. Mrs. Lim bought 7/8 kilograms. So this is not 7/8 units, this is 7/8 actual kilograms. She ate 1/4, this is units. She ate 1/4 units. How many kg left? Okay, if 1/4 units eaten, that also means 3/4 units left. And what's 3/4 of that 7/8 at first? So we're going to multiply, and that gives us 21/32 actual kilograms. Keith weighs 30 kilograms. Oh, he's super light, isn't it? He weighs 5/6 of his sister's mass. Find his sister's mass. Okay, so that means he weighs 5 units and the sister weighs 6 units. And these 5 units represent 30 kilograms. So basically 5 units is 30, 1 unit is 6. His sister's mass is just 6 units. That's 36 kilograms. Sarah had 56 stickers before she gave 3/8 of them to her brother. How many stickers left? Okay, if 3/8 were given, that also means 5/8 were left. And what's 5/8 of that 56? So we're going to multiply, of as in multiply. That gives us 35. 720 pupils in the school, 5/8 are boys. Okay, what's the difference between boys and girls? Alright, so if 5/8 are boys, that just means 3/8 are girls. In this case, I took a different approach. I took it as 8/8, total is 720, 1 unit is 90. Now, can you see that difference between the boys and girls is 2 units? So I found 2/8, because 1 unit is 90, 2/8 is therefore 180. And now we're going to do problem sums. Okay, the next few questions are going to look confusingly similar, so bear with me. I'm trying to point out a common mistake that most students make. Okay, let's begin. Timothy had 5/6 actual liters of paint at first. He used 2/3 of the paint. How much paint did he have left? Okay, so if 2/3 was used, that means 1/3 was left. And the total paint is 5/6 actual liters. So if I want to know the actual volume of paint that's left, it's 1/3 of this, isn't it? So it's 1 unit out of 3 units. So 1/3 of 5/6, we are multiplying, we get 5/8 liters. Behold, now it's a completely different situation. Look, Timothy had 5/6 actual liters of paint at first. He used 2/3 liters of paint. Can you see that there's a massive difference between these two questions? This is a fraction as in units. This fraction here represents actual liters. This question is much easier. Look, it is simply how much paint did he have left? He had 5/6 actual liters. He used 2/3 actual liters. It's a simple subtraction. So be careful. The moment units are included, okay, it's a totally different story versus without units. Let's try another question. Jerome had 2/7 actual kilograms of rice. Ridwan has 1/6 kg more than Jerome. How much rice does Ridwan have? So notice there's kilograms here and there's kilograms here. So Ridwan has 1/6 actual kilograms more. So J has 2/7, R has 2/7 plus 1/6 actual kilograms. So this is 19/42 kilograms. Simple addition. Can this question be changed? Now let me modify the question a little bit. Jerome has 2/7 kilograms of rice. Ridwan has 1/6 as much rice as Jerome. Can you see the difference there? There is no kilograms now. So how do we do this question? So 2/3, Ridwan has 1/6 as much as Jerome. Now, Ridwan has 1/6 as much of, has 1/6 of Jerome. Now we're dealing with units. Okay, it's no longer kilograms. So basically whatever Jerome has, R only had 1/6 of it. And this is 1/6 of, as in multiply, 2/7 kilograms. It's 1/21 kilograms. And the fun continues. Raju had this amount of actual liters of water at first. He used 1/4 of it. Now, is this liters? Nope. So this is actually dealing with fractions, yeah? He used 1/4 of it to water plants. How much water did he have left? Okay, so if 1/4 units were used, all right, that means 3/4 units left. So what's 3/4 units of this? Okay, so it's 3/4 of, as in multiply. This, remember, we cannot multiply mixed numbers. Change it to improper, multiply, and then express as a mixed number. Okay, Raju had 1 3/5 liters of water. He used 1/4 liters. Can you tell now? This is the much easier version because you just need to take how much water left. He used this, right? So this amount of actual liters used up this amount of actual liters. It's a simple subtraction. So just make sure that, it's not that simple, is it? First, we need to make the denominators the same. Yeah, and then we can subtract. So 12 units, can you subtract 5? Absolutely. So the 1 whole stays, you get 7/20. Do not forget the liters, your units. Okay, John drank 5/12 of a jug of orange juice. So this is units basically. The jug right now, 12 units. Jane drank another 1/3 of it. Hang on, it's the same jug. So why should the denominator be 3? I thought it's 12 units. Okay, so what can we do? John 5/12, Jane 1/3. But because it's the same jug, the denominators should be the same. Now anyway, how much did they drink all together? Okay, John drank this, Jane drank this. How much did they drink all together? Add the two fractions up. And voila, the total fractions should be 12 anyway. You should make the denominators the same. Simplify, you get 3/4 as a fraction. Charles spent 1/4 of his pocket money on stationery and 5/8 of that same amount of pocket money. What fraction left? Okay, so stationery 1/4. Well, let's make the denominators the same. It's 2/8. What's left? 1 whole minus 2/8 minus 5/8. That's 1/8. Amos gave 3/7 of his badges to Louis and had 1/6/8 badges left. Okay, so 3/7 given away also means 4/7 left. So if 4/7 represents 1/6/8, because that's 1/6/8 actual badges left, how many badges did he give? He gave away 3/7, didn't he? So find 1 unit, then find 3 units. You should get 126. There are 40 rows. Each row has 10. Can we not find the total number of seats? Absolutely. If 5/8 are occupied, how many not occupied? Okay, first find the number of seats. 1 row has 10. 40 rows means 400 seats. If 5/8 were occupied, 3/8 were not occupied. So what's 3/8 of that 400? In this case, of as in multiply, 3/8 of that 400 is simply 150. Mindy spent 3/8 of her allowance on groceries, then she spent some of it on transportation. In the end, she had 1/6 of her allowance left. Now, if you are dealing with the same total, again, the denominators should not be different. Okay, what fraction of her allowance spent on transportation? So anyway, 3/8 spent on groceries, 1/6 left. What amount was spent on transport? So basically take 1 whole minus this, right? 1 whole minus this, then obtain this. Okay, so because in subtraction, we have to make the denominators the same, you will get 11/24. A group of 300 children was asked, just one group, okay, about their mode of transport to school. All right, 2/3 go to school every day by car, the rest by school bus. What, nobody walked? Okay, never mind. So 2/3, there are only 2 modes here, by car or by bus. So anyway, because 2/3 went by car, 1/3 must be by bus, yeah? And by bus, that's 1/3 of 300. Here, of as in multiply. So you get 100. Actual children. Siti bought a cake. She kept 2/5 of herself and divided the remaining. Hang on. If 2/5 was kept for herself, what's the remaining? 3/5, isn't it? And the 3/5 will be shared among her 4 children. Okay, what fraction did each child receive? Alright, so if 2/5 was kept for herself, 3/5 must be for her 4 children. So I'm going to form an equation here. 4 children must represent 3/5 of the cake. 1 child, what do we normally do here? We divide by 4, don't we? Now, just because it's a fraction doesn't mean everything is different. No, it's the same. Just divide by 4. You must know your division rules. And the answer is 3/20 for each child. Mrs. Lee bought 4 or 5 kilograms of chocolate. She used 1/3 of it. Now, this goes back to the beginning of this section, doesn't it? Is this kilograms? Nope, it's units. It's 1/3 of this. All right. Now, she used this. How much left? Oh, if 1/3 was used, 2/3 was left. So what's 2/3 of for 5 kg? Here, of as in multiply. Chloe had 9/10 meters of a ribbon. She gave 5/12 of it to Debbie. Now, this is actual meters of ribbon. This is basically units. What length, okay, did Debbie get? Oh, 5/8. Sorry, 5/12. All right, so what's 5/12 of that 9/10 meters? We will basically multiply 5 of here as in times. Okay, simplify, divide by 3, divide by 3. That's 3/8 meters. During a 42-kilometer race, Timothy ran 9/21 of that distance. So this is 9/21 of this and walked the remaining. Okay, actually, if 19 units were walked, doesn't that mean 19 units ran, 2 units walked. So what's 2/21 of that 42? In this case, of as in multiply, 2/21 of that 42 km is 4 kilometers. Collie bought a pizza and gave 1/4 of it to his friend. He cut the remainder into 9 slices. Hang on, 1/4 given to friend. Doesn't that mean 3/4 of the pizza left? And this was divided by 9. Okay, let's do that. 9 slices represent 3/4. Each slice must be divided by 9. 3/4 divided by 9. So if you know your rules, you should get 1/12. A fruit seller opened a crate containing 30 apples. 1/5 of the apples, we know the actual number here, it's 1/5 of 30, were green. Half of the apples are red. Hey, we know the actual red apples as well. Half of 30, the rest are spoiled. How many could be sold? Ooh, tricky question. Now, we don't care about what's spoiled, right? Those can't be sold, ideally, unless you're rubbish. Your shop is not going to treat the customers well. Anyway, what's not spoiled? It's 1/5 plus 1/2. That is 7/10. Notice what I did there? If they're asking, what can be sold? The greens and the reds. So what fraction in total? The greens and the reds. It's 1/5 plus 1/2. That's 7/10. What I'm skipping here is making the denominators the same, but it should get the same fraction here. So I'm interested in what 7/10 of 30 of here as in multiply. That's basically 21 apples that can be sold. Mrs. Tan bought 144 actual fruits. 1/3 of these fruits were apples. 1/4 of these fruits were pears. The rest oranges. Okay. What fraction were oranges? First of all, 1 whole minus apples minus pears. That gives us 5/12, representing oranges. Okay, how many actual oranges is that? It's 5/12 of that 144. So that means multiply and you should get 60. Level 2, so there are 2/3 as many boys as girls. The way you should read that is boys 2 units, girls 3 units. What fraction of the total, hang on, doesn't that mean, okay, like I said, boys 2 units, girls 3 units. Okay, now girls must be 3 units. Total children is 2 plus 3, that's 5. A box contains 120 white and black marbles. The number of white marbles is 20 fewer than the number of blacks. Now, this is easy to work with, okay? So if we have white being 20 fewer, that also means blacks 20 more. And the total is 180. So 1U is therefore 80. You can plug this in. What fraction of the marbles is white? Hang on, of the marbles, that's 180, isn't it? What's the fraction that's white? Okay, white is therefore 80. So the required fraction is 80 over the total. Simplify, you should get 4/9. A cup is 1/3 full of water. The water is then poured into an empty jug, which can contain twice the capacity of the cup. Hang on. If the cup is 1/3 full, this is another way of saying the cup's capacity is 3 units. So what I do is, the capacity of a cup is 3 units, and 1 unit was filled. All right, the jug has a capacity twice that of the cup. Doesn't that mean the capacity is 6 units? Now the water is then poured. Isn't the same unit of water poured in here? Okay, so this means that 1/6 of the jug was filled, but what fraction was not filled? It's 1 whole minus 1/6, that's 5/6. In a stadium, there are 700 seats, and 1/4 of them, well, we can find out the actual number of first class and non-first class, by the way. 1/4 first class, non-first class must be 3/4, right? So we can actually find the actual number of these two categories. How many first class seats must be added? Hang on. Doesn't that mean the total is no longer 700? So how many must be added so that the number of first class seats will be increased to 3/10 of that new total? Okay, the total is no longer 700, by the way, if you add more first class seats. Now let's do that, shall we? The way I think about this while using a model is like so. 1/4 first class, 3/4 not first class. Okay, let's find out the actual number. Plus, there's a certain number of first class seats to be added, such that this new mysterious total, is 3/10 first class and 7/10 non-first class. Do you notice something? The number of non-first class seats hasn't changed. So if we can find the actual number of non-first class seats, that's going to make up 7/10 of that new total. Okay, let's do a bit of work here. So 1/4 not first class, 3/4 not first class. So what's 3/4 of that old total, 700? That's 525. So basically, these three units, 525. That's 7/10, by the way, of the new total. That's 525. Okay. At first, 175 first class seats. Think of 175 here. Now, if 7/10 of that new total is 525, one unit must be 75. Okay. Now, what's 3/10 of that new total? That's 225. Again, in case you are not sure, what do I mean by new total? It's basically no longer 700. It's 700 plus this mysterious number here. Alright, anyway, 3/10 is 225. Oh, so if this is 225, adding this part here, and the first class seats at first was 175, how many seats got added? It is 225 minus 175, that's 50. When 3/8 of a number is increased by 18, the result is 54. What is the number? Well, let's conceptualize this. When 3/8 units has 18 added to it, the result is 54. Can we not find the value of these 3 units? What is the number? We're interested in the 8 units in the end. But basically, 3 units plus 18 is 54. Well, what we can do is therefore, 3/8 is therefore 54 minus 18, that's 36. 1 unit is 12. The number is simply 8 out of 8 units, 96. A pole was 2 actual meters long. Jack painted 1/4 of it red. Now, is this meters? Nope, this is units. 2/5 of that same pole, hang on, shouldn't the denominators be the same here? Because we are talking about the same pole, right? And the rest green. Find the length that was painted. Green, special requirement in centimeters, and they gave you meters at first. Okay, green is basically this last part here. So we're going to take 1 whole minus red and blue, shall we? So red and blue, 1 whole minus red minus blue, make the denominators the same. You will get 7/20. But this is 7/20 as in units. What's 7/20 of 2 meters? Of as in multiply. Don't forget, 2 meters convert to cm, and 70 cm will be your answer. Joel's salary is 2/3 of Melanie's salary. Okay, the way I think of this is 2 units on the left goes to the left. The numerator is pointing to Joel being 2 units, Melanie having 3 units. Okay, well, Melanie's salary is 9/10 of K. So we've got 3 people here. Now, I am going to use combined ratios here. You should know ratios. If you don't, there are other videos for that. So J, 2 units, M, 3 units. M, 9 units, K, 10 units. Why should M be 3 and 9 at the same time? Let's make it the same, shall we? So multiply by 3, that's 6, 9, 10. Okay, what fraction of K salary, notice, of as in the denominator here. So of is pointing to the fact that K's units will be the denominator, like so, and Joel's units will be 6. Simplify, you get 3/5. Mei Ling bought a TV and a computer. The mass of the TV was 12 actual kilograms. 3/5 of the computer weighs as much as 3/4 of the television. So we are going to multiply. What is 3/4 of this? Okay, so 4 the TV was 12 kg. 3/4 of the TV, we're going to multiply, that's 9 kilograms. And we are told that 3/5 of the computer's mass is equal to this number here, 9 kg. You can find 1 unit, you just divide by 3. Then find 5 units, you just multiply by 5. You should still come to the same answer, 15 kilograms. In the figure below, B is 3 times the size of C. Oh, that makes sense. C is larger than C. B is larger than C. And A is 4 times that of B. Oh, okay. All right. What fraction of the whole figure is B and C? Well, let's assign units, shall we? Let's call C 1 unit. What's 3 times of that? That's B, 3 units. And what's 4 times of this? That's 12 units. Okay, what's fraction of, as in, this is the denominator, the whole figure. Well, what's the whole figure? That's 1U, 3U, 12U, isn't it? Is B and C. Well, what's B and C? That's 1 plus 3, isn't it? So that's 4 over 16. And if you simplify that, that is a quarter. There were 16 pupils in the class at first. 12 of them were girls. 2 more boys and 2 more girls joined the class. In the end, what fraction were girls? Okay, 16, 12 of them were girls. So we know the number of boys actually. So let's do that, 12. So here is just making sure your information is clearly represented, yeah? So boys at first is 4. Now what's the girls after? That must be 12 plus 2. What's the boys total after? Okay, it's 16 at first, right? But 2 boys, 2 girls joined, that's a total of 16 plus 2 plus 2. Okay, so what fraction of the pupils in the class? That means this right here is the new total, were girls, and that's the new number of girls. That's 14 over 20, simplify, 7 over 10. There were 16 pupils in the class at first. 12 of them were girls, okay? So we know the number of boys and girls. 2 more boys and 2 more girls joined the class. So the total is no longer 16, is it? In the end, what fraction of the pupils in the class were girls? Turns out we're not interested in the number of boys, okay? And this question basically requires you to keep track of all the numbers that are going on. So we know that we want the total number of pupils as the denominator, and the numerator is the new number of girls, okay? So if we are talking about 12 of them being girls, okay, that's 12 at first. So what's the girls? Actually, we don't need the number of boys. Now, girls after must be 12 plus 2. Why? 2 more girls joined. But the total after is not 16 anymore. It is 16 plus 2 girls plus 2 boys. So now just make sure you have the correct fractions, simplify, and that's your answer. And this concludes fractions part 3. Now, there are more coming up, so in the meantime, have a nice day.